Hi guys, this is a small video on prefix code. I hope this video will be useful for you people to understand the notes uh, in a easy way. Now, the first I'll start with the binary sequence. Okay, so what is binary sequence? A sequence consisting of only 0 and 1. Okay, so any sequence which contain only 0 and 1 is called as binary sequence or binary string that we used to call. Now example we have taken here, if you observe, this is 000 010 110 111 and 1100. So we have taken five sequence. So 000 010, this 111 and this all are containing only zeros and 1. So therefore we are going to call this as binary sequence. Okay, so in general binary sequence are used to as a codes for some symbols to send the messages through transmitting channels. In further studies I think it will comes to know how we are going to use the binary sequence to code the messages or to represent the symbols. Okay, now we'll concentrate on prefix code. Prefix code is a set of binary sequence. Okay, it is a set of binary sequence, okay, represent the symbols, means that binary sequence which we are going to consider will represent some symbols. Okay, then P is called prefix code. We can also call that as Huffman code. Okay, if no binary sequence in P is the prefix of some other sequence. So for example, if you go, I think P1 we have taken, you can easily observe here. We have P contains 5 binary sequence 100, 1101, 111, 110. Now I want to know this P1 what we have taken is a prefix code or not. Of course, yes, because you consider any binary sequence here. Suppose if I take 10, this is not the prefix of any other binary sequence. Likewise, if you take 0, okay, 0, this is a binary sequence. This is not the prefix of any other binary sequence in the same set. So like that, you take any of the binary sequence in this set P1, it is not the prefix of any other binary sequence. In a simple manner, if I want to say 0 is not the beginning of any other binary sequence, means no binary sequence in this set starts with this binary sequence. So no other binary sequence starts with 10. No other binary sequence starts with 1101. No other binary sequence starts with 111. No other binary sequence starts with 1100. So therefore we can consider P1 as a prefix code. I can tick this as prefix code. Now I'll come for the second example. I have taken, see, 101 00 01 000 and 011 we have taken. So again P2 is a set of binary sequence. Now I have to check whether it is a prefix code or not. Now if you take that thing, what is the prefix code? No binary sequence in the set is the prefix of some other binary sequence in the same set. Now here, for example, if I take, okay, 000 I will take, okay, 00 I will take the binary sequence 00 in this set, and this is the prefix of two other binary sequence. See, if you want you can go for this. See this 000 what we have taken, this starts with the binary sequence 00. Correct. So 00 is the prefix of the binary sequence 000. Also this 00 is the prefix of this 001, means 001 starts with the binary sequence 00. So therefore this set is not a prefix code. Correct. Now we are going to take few examples on that prefix code, how we are going to represent the binary sequence for the symbol. Now for that we need the help of a tree. I think you can find out here the binary tree, complete binary tree that we have taken. Now here one thing we have to say, always the left edge which is going out from that vertex we have to label it by 0 and right edge is by 1. Same thing here, 0 and here 1. Same thing here, 0 1. See here 0 and here 1. Now from here 0 1 0 1. here 0, 1, correct? So now here the leaves of the binary tree. Leaves means what? It is the vertex with degree 1 of the tree. Now here all the leaves is been considered it as some symbols A, B, C, D, E, F, G, H, like that. Now first I will come for A. Now what is the binary sequence represented by this A? Very simple. See, I can come with this from here to here 0, again it is 0, again it is 0. 3 edges. A is at level 3 and that level will be counted by this edges. All the edges by represented by 0 are labeled by 0. So therefore I can consider A represented by 0, 0, 0. Likewise I have to go with B now. How I got B as 0, 0, 1? Simple. It started with this. B is also at level 3, correct? Now I can start like this 0, correct? Then it will comes again 0, then it will comes to this. So 0, 0, 1. That's what I have taken. For B it is 0, 0, 1. Why C represented by 0, 1, 0? Simple. Again I start with here. It is 0, 1, 0. Correct? Now for D 0, 1, 1. See, that's what we have taken, D. Now last one I think I'll go with in general for H. See, what is the binary sequence represented by H? See, this is 1 and again this is 1 and again this is 1. So H will be the binary sequence which is represented by 1, 1, 1. H symbol represented by binary sequence 1, 1, 1. So for F, I think you can easily calculate. It is see here 1, 0 and 1, correct? 1, 0 and 1. So that's what, see here we have taken. F means 1, 0, 1. Okay, this is the way that we can represent any symbols by binary sequence by the use of tree, binary tree or complete binary tree. Okay, now we're going to take one example there. It will be clear for people. Construct the binary tree that represents the following prefix code. See, this is the prefix code that they had given. What is that? P is 0, 0, 0, 1, 1, 0, 1 and 1, 1, 1. Okay, this is the prefix code that they had given. Now by observing that, see, theoretical part you can go through. Now here itself you can find out. See, P contains the maximum level is 3, because see here this also contain 3, this also contain 3 element, means definitely it should contain 3 edges. To get 1, 1, 0 I should get 3 edges. To get 1, 1, 1 also I should get 3 edges. So this tree contains maximum level 3. That's what we have taken here. Level can be identified by the sequence. Now I can go for the concept now. See, I have to get 0, 0, correct? I have to get 0, 0 means what? 0, 0 means what? 0 can be taken for the left edge, correct? Now if I want to get 0, 0, so I can get 2 left edges. So I can go like 0, 0. Correct. So that's what I got, 0, 0. One binary sequence of the P I got. And also I need, see here, binary sequence, second binary sequence I need here 0, 1. How I can get? So 0 for left edge, 1 for right edge. Correct? So therefore 1 left edge, 1 right edge. See here on the tree, same thing. I have taken 1 left edge, 1 right edge. So I got 0, 1. Correct? So that's what I got, 0, 1. Next I need, carefully observe here, I need 1, 0, 1 here. Correct? I need 1, 0, 1. How I can get this 1, 0, 1 in the binary tree? 1 means right side, correct? Right edge, then left edge, then right edge. So I can go like this, right edge first, 1. So I can go like this, then left, then right, correct? So I can get 1, 0, 1. Similarly, I can get 1, 1, 0. Similarly, I can get 1, 1, 1. So this is the way that we can construct the tree for any prefix code which they are going to give. 0 means left side edge, 1 means right side edge. That please we can remember. Okay. Next example that I'll go with. See, obtain the prefix code represented by the following tree that they had given. They had labeled, and also the leaves of the tree also can be referred by A, B, C, D, E, something like that. Now it is very simple. One can easily tell. What is the binary sequence for A? One can tell, sir, it is 0, 0, 0. What is the binary sequence for B? It is 0, 0, 1. What is the binary sequence for C? It is 0, 1. Correct? What is the binary sequence for D? It is 1, 0. What is the binary sequence for E? It is 1 and 1. Correct? That's what we have taken here. See, carefully observe. For A, we have taken 0, 0, 0. For B, we have taken 0, 1. For C, 0, 1. For D, 1, 0. And for E, it is 1, 1, 1. Same thing. Okay? Now, we can take one more example here, the quite interesting one. They had given certain list over there, first list, second list, third list, and they are asking us to decode this. For that, they had given some binary sequence for A, B, C, D. Correct? A represent 111, B represent 0, C represent 110, and D represent 1101. Now, by keeping these in our mind, we have to split first these lists in such a way that I am going to get either A or B or C or D or E. So, by keeping these in our mind, so I have to split this. So, I am going to consider the first one. Okay. Now, carefully observe here. I have taken. So, I have splitted that as 1, 0. Then 0, then 111, then 1101. Correct? So why I splitted that means they had given binary sequence only for A, B, C, D, E. Correct? So I have to split according to the things which I am going to get, either these 5. Correct? See, 1, 0 is nothing but E, and 0 is nothing but B. 111 is nothing but A, and 1101 is nothing but D. Means the first sequence what they had given or the list can be decoded as EBAD. Correct? EBAD. So likewise, I can take the second one. They had given 10, 1111, 00, 11, 0000, 1101. Now how I can split this? Again, I can't split as I want. I have to, while splitting these lists, I have to keep in mind that the given symbols, what they had given. A, they had given 111. Say here, A, they had given 111. B, they had given 0. C, they had given 1100. D, they had given 1101. And also they had given E10. So to split this, I have to keep those things in my mind. Correct? So according to that, if I split, I can split this second one like 10, then 111, then 10, then 0, then 1100, and 0, then 1101. So 10 represents E, 111 represents A, 10 represents A, 0 represents B, 1100 represents C, 0 represents B, and 1101 represents D. So therefore, we can write down the entire list as EAE BCBD. This is the decoded version of the given list. Correct? Similarly, we can go with the third one also. We can easily find out that third one can be splitted as 1101, 111, 1100, 10. That can be decoded as D, A, C, E. Finally, that entire thing can be represented or decoded as DACE. Correct? That's the thing that we have to remember. Now we can concentrate weighted tree. See, this is the theoretical concept we have to know. Consider n set of. See, generally I can tell, I don't know whether you people are observing this or not, whether means clarity is there or not, but I can tell weighted tree means what. So first weight has to be assigned to each of the leaf of the tree. So leaf means what? Degree 1 vertex of the binary tree. Each degree 1 vertex has to be assigned some weights. That's the first thing. Correct? Now, to get the weight of the tree, so what we have to do is we have to take, see, this one, sum of weights of the leaf into the level of the the same vertex. Weight of that vertex into level of the vertex has to be taken, and we have to take the sum of all vertices of degree 1. Okay, then I can call that the weight of the tree. Now example if you take, then it will be clear to you people. See here, I have taken one tree. See if, these are the four leaves that I have. This one, this one, this one, and this one. Correct. Now this vertex has been given weight 8. This vertex has been given weight 7. This vertex has given weight 5. This vertex has given weight 3. Now I want to get the weight of this tree. So first I have to go with 8, this vertex. So this is the weight 8 for this particular vertex. But this vertex is of level what? This vertex is at level 3. See, 1, 2, 3. Correct? So I have to take 8 into 3. Similarly, I can come for this. Weight of this vertex is 7. The level of this vertex is, what is the level of this vertex? Again 3. See, 1, 2, 3. Correct? Now weight of this is 5 and level of this vertex is 5. And weight of this vertex is 3 and the level is 1. So therefore weight of this tree is, see, 8 into 3. 8 is the weight, 3 is the level of that vertex. Then 7 into 3, 7 is the weight of that vertex and 3 is the level of that vertex, plus 5 is the weight of that vertex into level is 2. 3 is the weight of that vertex and 1 is the level. So if you simplify that, you're going to get 58, and 58 will be the weight of this tree. Correct? Now come for this one. I think here itself we'll try to write the things over here. See, all degree 1 vertices has been given weights. 1, 2, see here I have taken, and one more here and one more here. So these vertices has been given weights. Correct? Now I have to get the weights of this one, weight of the entire tree. Now first, kindly can you help me to get that? First I am going to take first vertex. It is 5 because weight of this vertex is 5. I have taken 5. Can you tell me the level of that one? It is 3. Correct? Very good. Now I am going to take that plus. Now what is the weight of this vertex? It is 3 into what I have to take, level. Level is also 3 again, plus. So level of this vertex is 2 and weight is 2. So I can take 2, 2 plus. So I can come for this vertex. So weight is 3 plus level into level is 2 plus weight of this is 4 and level is 2. So I can take this one. So if you simplify, you are going to get 15 plus 9 plus 4 plus 6 plus some 8. This is 15 plus 9, 24, 28 and 34 plus 42 I think you're going to get. Correct? So 42 is the weight of this tree. Weight means what? Weight into level of the vertex plus weight into level of the vertex, weight into level of the vertex, weight into level of the vertex, weight into level of the vertex. Correct? So that's what we have to go with. Now optimal prefix code. So this is the last part in this video. So concentrate, very simple one and important too. Optimal prefix code, with the example I'll go with. See, what they are going to ask is obtain the optimal prefix code for the prefix code that they are going to give. For the given weights they are going to ask. They are going to give the weights. See, they had given weights here in random way, 4, 15, 25, 5, 8, 16. Like that they are given. For this weight, we have to get the optimal prefix code. How we are going to get? Very simple. How many elements are there? First you identify. 1, 2, 3, 4, 5, 6. 6 elements are there. So I am going to take 6 vertices now. Isolated vertices. 6 vertices I am going to take, and I am going to assign these weights in increasing way or in non-decreasing way. So first I am taking 4. Then next highest weight is 5. Next highest weight is 8. Next highest weight is 15. Next highest weight is 16. Then it is 25. Correct? So I have taken the symbols A, B, C, D, E, F. Correct? Now it's very simple one. Among these now, second step. So identify the minimum 2 weights. That is 4 and 5. Correct? So corresponding to the vertices A and B. Now join those two to the new vertex. Join these two to the new vertex V1 and add these 2 weights 4 and 5. See, that's what I have done in the second step. I have joined AB for the new vertex V1. Weight of that is 9. 4 plus 5. Correct? Now V1 is with weight 9 and remaining vertices I have not disturbed. It is same. C is there with weight 8. D is there with weight 15 and F is there with weight 16. F is there with weight 25. Now among this V1, C, D, F and E, So identify again the two minimum weight vertices, that is V1 and C. Correct or not? These are the two vertices among all the weights having minimum weight. So now we have to join V1 and C to the new vertex called V2. So in the next step, we have done the same. See, here V1 is there, here C is there. We are adding these two to the new vertex. We are joining those two to the new vertex V2. How I got 17? Because V1 got 9 and C got 8. So if I add that, I'm going to get 17. So remaining vertices I kept as it is. I have not disturbed anything. It is 15, 16, 25. Correct? Now I have with me the vertex V2. Correct? With weight 17 and D with weight 15 and E with weight 16 and F with weight 25. Correct? So among which now I have to identify two minimum weights. So here it is 17. V2 is 17. This is 15. This is 16, 25. So these are the two vertices I can say. D and E are the two vertices with minimum weight now. So I have to join these two to the new vertex V3. So that's what we have done here. Carefully observe. This part I kept it as it is. This part I have kept it as it is. We have joined the vertices D and F to V3 and sum of that is 31. Correct? And I kept F as it is. Now we have with us three vertices now. Carefully observe. V2 with vertex 17 and V3 with weight 31 and F is with weight 25. Now among these three, you can identify the two vertices with minimum weight. So hopefully that is V2 17 and F 25. So in the next step, I have to join V2 and F, okay, to the new vertex V4. So that's what, V3. That's what we have done for V4, That's what we have done here. See, this is V2 and this is F. I am joining those two to the new vertex V4 and the weight will be 42. Same thing, I have joined only those two vertices and I kept this DE as it is, V3 31. Correct? Now we left with only two vertex. One is V4. Just now what we got, that vertex V4 and vertex V3, that is with 31. Only these two vertices are there and I have to join those two vertices for the new vertex called it maybe V5 or anything. So now we are joining that thing. Carefully observe. This is V3 and this is V4. This is V4. I'm sorry. This is V3. I'm joining those two to R. So V is 42 and this is 31. No. So our weight will be 42 plus 31. Correct? Now these are the symbols that I'm going to get. A, B, C, F, D, E. Correct? So for degree 1 vertices or leaf of the tree, symbols are there. So now if you want to get to know what is the weight, optimal prefix code that they're asking. So first I'll consider the weight of that one. See, I got the weight of the tree which I've taken as 4 into 4. Why? Because A, first one. See, if you want you can come with this. A is there here. So this is having height 4. See, 1, 2, 3, 4. So height of that vertex is 4 and the weight is also 4. That earlier they had given. So we have taken 4 into 4 plus 5 is the weight of that vertex B and level is 4. Then 8 into 3, 15 into 2 plus 16 into 2 plus 25 into 2 and totally we are going to get 172. Obtaining this weight and the prefix code, the procedure which we adopted is called as Huffman's procedure. Clear? Hope you understood. In the next class, we are going to, in the next video, we are going to study what is optimal prefix code and how we can get that thing. Hope you understood. Thank you very much.